The trigonometric models is a worksheet that has all notes, and then it's going to be followed up with a practice worksheet that you're going to do on your own. So take good notes here. These are not exactly easy. So we know from graphing trig functions that a sine function has a particular shape, and I'm going to give a really ugly sketch. Whoops, that's terrible. But the sine does start at the origin, and then kind of do one of those. And cosine starts at the upper end of the amplitude and then stretches like so. Now at the top of your worksheet, you're going to notice a variety of formulas. I tried to come up with every single formula we might need to come up with anything in this trig unit. Now remember, models indicate that we're going to be referring to application problems. So the b, which is the number that's inside by the variable, can be calculated by doing 2 pi divided by whatever the period is of the function. It's also calculated by 2 pi times the frequency. We haven't talked too much about frequency. Frequency and period are related because period is the inverse of the frequency, or frequency is the inverse of the period. So here's formulas that you can use to find the period of a function. Vice versa, here's formulas you can use to find the frequency of a function. And then the a value that I'm referring to is the amplitude that's in front of the trig function, and the k value would be the vertical shift of up or down, and this is how you can find it. So I'm going to leave those formulas up at the top. I'm not going to redraw the sketches each time because we're pretty good at those. But these first two problems say write a sinusoidal function with maximum at point A and minimum at point B. So first thing I'm going to do is kind of do a really ugly, actually that's not bad, sine graph. Whoops, that's bad. And then pretend that we've got a upper and lower amplitude line here. And of course the midline's in the middle. Now, first thing I'm going to do is I'm going to label those upper and lower lines. I see that the maximum occurs at 8 and the minimum at -8. So you might be able to tell just visually that 0 is in the middle. Now, if you weren't able to tell that, what I'm asking you to find is the k. Remember, the midline is the k. So had I used my formula from the top, max plus min divided by 2 is 0. So there's your k value. Now, the amplitude, I think, is pretty obvious here. It's 8. But you can find that by doing the max minus the min divided by 2, which is 16 cut in half, or 8, and that is my a value. Now, the other thing we need to figure out for our sinusoidal function is we need to know the value of b. The b I'm referring to is that guy right there, not point B. So I look at my formulas up here. It says you could use one of these formulas. Unfortunately, I don't really know anything, so I think I have to resort to coming up with points. So the maximum, which is right here, occurs right here, is at the point pi, comma 8. So over pi units, up 8 units. And then the minimum, which is right here, is 3 pi, -8. So I think if you use your dividing skills here, if this is 1 pi, the midpoint right here is 2 pi, 3 pi, and then 4 pi. So it turns out that the period of this function is 4 pi. Unfortunately, I don't want the period, I want the b value. So I see right here in my formulas, 2 pi divided by the period is the b value. So 2 pi divided by the period, if I reduce that fraction, I get a 1/2, almost home free. I just found my b value, I know my a, and I know my k. So they told me it was a sinusoidal graph. The a goes in front, so 8 times the sine of b times x. So the b we just found to be a 1/2 x. And normally I'd say plus k, but it's plus 0, so I'm just going to write this is my function. Okay, next function. Again, it's sinusoidal. Oh, jeez. If I could draw a horizontal line, that would be good. Then, I don't really need the drawing to be too beautiful, but again, they give me a max and a min. And I'm going to label the max and min horizontal lines. He's a 1 and he's a -3. You might be really good at visualizing midpoints, but otherwise you can use your formula. The k, which is the midline, is the max plus the min divided by 2. So in our case, k equals -1. And then the amplitude is the basically the distance from the midline up to one of the upper line or the lower line. So our a value is our max plus our min. Oops, max minus min, excuse me. 1 minus negative 3 cut in half. So that's 4 cut in half, which is a 2. So the A value is a 2. We'll come back to that in a second. They told me my maximum point occurred at 2 pi comma 1. So if this is 2 pi, this must be 4 pi, this must be 6 pi, and this must be 8 pi. So what I just realized is 1 complete cycle in 8 pi, the period is 8 pi. I don't care about the period, I want the B value. The B value is 2 pi divided by the period. So our B value is 1/4. Almost home free. I have the K value, I have the A value, I have the B value, and I know it's sinusoidal. So the A goes in front, 2 sine, and then 1/4 x, B times x, and then plus the K. Instead of plus a negative 1, I'm just going to write minus 1, and that is my trig function. Okay, next set of problems. Now we get to the story problems. Displacement of a boat's water line above sea level as it moves over waves can be modeled by that trig function. They want me to graph the height of the boat over a 3-second time interval. Well, this will be good. A couple things I notice. 2 is the amplitude, so I'm going to do my best here to draw in some upper and lower amplitude lines. And I notice there's no K value shifting up or down, so my midline is 0, my upper line is 2, and my lower line is negative 2. The other thing I notice in my formula is inside the sign is 2 pi t. What that tells me is 2 pi is the B value. Since I want to actually graph it this time, I don't care about B, I care about the length of the period. So the period, if I look at this formula, is 2 pi divided by my B value. Well, cool, 2 pi divided by pi is 1. So it turns out that if I graphed one sine cycle, which I'm going to do really sloppily, 2, 3, oh goodness. From here to here is one sine cycle. Gosh, that's bad. From here to here is 2 sine cycles, and from here to here is 3 sine cycles. But remember what we said, the period is the length of one cycle. So it looks like it's labeled in seconds, by the way. So for it to finish one sine cycle, that's a value of 1. This would be a value of 2. This would be a value of 3. Yikes. If I wanted to label in the middle here, this would be 0.5. This would be 1.5. This would be 2.5, but that's pretty obvious. Hopefully you can graph a little better than I can. So what I realize here is the important parts about finding what the graph looks like. I need to know the period, and I'm going to use the B value to determine the length of the period. The amplitude lines are important and are affected by the A value of the function. Apologies for how ugly that was. Okay, number 4. The height of the water in a bay varies sinusoidally. Okay, good to know. Off the coast of Maine, the high tide is 10, and it occurs at 5 a.m., and the low tide is 2 and occurs at 3 p.m. Now, first of all, we're going to have an army time issue. If I call 5 a.m., 5 a.m., and 3 p.m., 3 p.m., it's a little confusing. I'm going to change this to army time. I don't know if you ever heard of this. When you get to noon, they just keep counting. So like 1 o'clock would be 13. So 1 p.m. is 1,300 hours. 2 o'clock is 1,400 hours. So 3 o'clock is 1,500 hours. So we're going to call it 15 a.m., which is kind of a stupid way to say it. But I need I need this to work for my brain, and that's how it works. Oh goodness. They told me about high and low tide. High tide was 10 feet, and low tide was 2 feet. Now, I don't think this midline represents 0. The midline, remember, is the K, and he's the max plus the min divided by 2. So 12 cut in half is 6, which I know some of you can do that visually. Sorry about the bell. You don't have to do that, with a formula, and good for you. So I also know I'm going to have to find the A value, the amplitude, which again, many of you can look at this and say, hey, duh, the A is 4. But if you can't, I can sometimes. It's the max minus the min divided by 2, which indeed is 4. Now, I'm going to go ahead and sketch a graph, even though they didn't ask me to. And they said the high tide of 10 feet occurs at 5 a.m. Now, remember, for a sine graph, the starting point is here. So this right here represents 5 a.m. which means if this is 5 a.m., this must be 10 a.m., and this must be 15 a.m., which makes me very happy because that was supposed to be the low tide, which means this guy is, let's call it 20 a.m., which we know is not 20 a.m., but it's 100 hours. So the period length for this tide is 20 hours, but for me to write a formula, I need to know the b value. So the b value is 2 pi divided by the period. So if I reduce that and I want to leave it as pretty as possible, I'm going to leave it as pi over 10. Almost done. Y equals, the a value goes in front. They wanted a sinusoidal graph, so sine. B times x, or t in this case I believe, is pi over 10 times t. It doesn't matter what variable you use, but they did ask me to use t. And then plus the k value to shift the midline up, plus 6. Good time. Okay, same formulas at the top. Number 5, we've got a paddle wheel of the SS Beaver is 13 feet in diameter. And it revolved 30 times per minute. So what they just told me, they didn't call it this, but this was the frequency of your paddle. Using that top speed of 30 times per minute, starting from a point at the very top of the wheel. So if I think about what's going to be happening here, is if I was like a bug stuck to the end of the wheel, this is the path I would be taking. Above water, below water, above water. I shouldn't say above water, but above the midline. Goodness, that's a terrible graph. Oy! They also kind of hinted at amplitude lines for me. They told me that the paddle is 2 feet below water at its lowest point. So this bottom amplitude line is a -2, and then the fact that it's got a 13-foot diameter tells me that when he's up at his highest point, he's 13 feet above that. So he must be an 11 for the top amplitude line. I kind of already know what the amplitude is, but if you are thinking you might not, remember amplitude is max minus min cut in half, so that's a 6.5. Oops, what did I just find? Not that. I just found amplitude. The midline, the K, is my max plus my min cut in half, so 9 cut in half is 4.5. And I know they didn't ask me for a picture of this graph, but I often find that a little sketch of it really helps me visualize what's happening. So, I don't know if you can tell from this graph, but since it starts up at the top, we're going to call it a cosine. And the amplitude, I found, oh, I'm not ready to write the equation. I still haven't found the period. So the frequency is 30, which means the period is 1 over 30, which is very exciting, but it doesn't matter to me because all I need to do is write the equation. So if I want to know the b value, I can use this form of the b value equation that says b equals 2 pi times the frequency. So the b value for my equation is going to be a 60 pi. Now I think I know everything I need to know. I know a, k, and b. So the a value goes in front, 6.5. It was, I notice now, a cosine graph if I start at the origin. B is 60 pi, and then I think again they wanted me to use t instead of x, and then my midline was shifted up 4.5. All right. Number 6, Ferris wheel. Now this got me at first. I had to key this twice before I could figure out what I was doing wrong. It says a radius of 20 feet. I do not give a hoot about the radius of a Ferris wheel. What I need to know is about the diameter. The diameter is going to be 40 feet because diameter measures from the bottom to the top of the Ferris wheel, and that's what I'm interested in, the position of the person off the ground. So it operations 3 revolutions per minute. So what they just told you was a frequency. And they didn't tell me what time interval they want for this problem, so I'm just going to assume minutes is an okay interval. If for some reason they wanted the speed of the car in, feet per second, then we'd have to do some converting, but we're just going to keep it in terms of minutes for now. There's my frequency, so let's go ahead and I know the frequency is going to help me find the b value. Using this formula right here, b is 2 pi times the frequency. So the b value for this problem is going to be a 6 pi. Come back to that in a minute. The bottom car is 4 feet above the ground. So at the very lowest point of the Ferris wheel's trip, he's already going to be 4 feet above the ground. And if he's got a diameter of 40, the highest point that a person in a car can reach is 44 feet because he started it up 4, so 40 after that would be 44. So the midline, max plus min divided by 2 is 24. Again, if you could visualize that without doing the formula, great. And the amplitude value is max minus min cut in half, so that would be a 20. Again, if you could calculate that or visualize it, that's great. And then one more clue, they told me when t equals 0, the height is 44. So that's important. They tell me where time is starting. So apparently this graph is going to look something like this. So now that I see a picture of how this is going to be sketched out, I can see he's a cosine graph. If I want to start at the origin, with an amplitude of 20, cosine, the b is a 6 pi. They want me to use t for time. And then it was a midline shift of up 24. That is my function. And I think that's all they wanted. And then number 7. Harmonic motion has a lot of examples about tuning forks and frequencies of different notes on a music scale. It's actually kind of interesting if you're interested in music. But it says the vibrations cause a change in pressure, and a middle A provides a frequency of 440 hertz or cycles per second. You strike a middle A and it produces a max pressure of 5 pascals. So first thing they want us to do is write a sine model that gives the pressure as a function of time. Now don't get nervous here. They're using P for pressure instead of Y or H for height. Oh, by the way, I think in a previous problem I was supposed to use H for height, not Y. My bad. This does not represent period, but they did kind of sort of tell us the period because they told us the frequency. But again, since I want to know the actual sine model, instead of calculating the period this very second, which wouldn't be hard, it's just 1 over 440, it's the reciprocal of frequency, I actually need to know the b value of my function. So remember, he's 2 pi times the frequency. So that would be 880 pi is the b value. The max pressure of 5 pascals is just their secret way of telling you your amplitude, and the midline is always 0 for these problems. So, oops, I did it again. They wanted, oh geez, they wanted P for the output variable to represent what we used to call Y. We just decided that the pressure was 5 is the A value, and they told me it was a sine function. I just calculated the B value to be 880 pi, and then times the time, don't know what that is, and there's no vertical midline shift, so that is the function. Now they want me to graph the model. Ugh. You've seen my graphs. Actually, that's not bad for me. And, oh goodness, I don't know why it's so hard to draw a horizontal line, but it is. That's a 5, that's a -5. Oh goodness. The important thing though when you graph this is you mark off the quarter points. Remember we decided earlier the period was 1 in 440 seconds? So the end of the cycle is 1/440th. If I cut that in half, that's 1/880th. If I cut him in half, that's 1 in, let's see, 1760. And then this is 1 1760, 2 1760, so this would be 3 1760. Gag. Of course, decimals would be fine, but fractions are actually easier to work with, especially if you don't have calculator access. And then number 8. Let's get that cursor off there. The motion of a pendulum can be modeled by this function, where d is the pendulum's horizontal displacement. So what they're referring to is like if you've ever seen a grandfather clock and you know it swings back and forth. So you know, when it's swinging, it's over here, and when it swings over here, it's right there. If you measure his horizontal displacement, they're just asking you how far to the right and to the left does he swing. Now, if it's a true balanced pendulum, not drawn like I did, it's going to have an equidistant horizontal displacement in both the right and left directions. And there's a really nice diagram of this in your book on page 835, so I instruct you to look there. The question is, how far horizontally does the pendulum travel? Well, if you look at your equation, there's actually no work. The amplitude is referring to the displacement of the pendulum, It goes up 4, down 4, up 4, down 4. So the horizontal displacement is simply 4 feet. It's the amplitude. All right, this is a good one. This formula is referring to, oh gosh, I can never remember whose law this is. Some law in physics about a spring. Hooke's law, maybe? And the way we're defining it is it's a times the cosine of the square root of k over m. Now, just so you all realize, it's the square root of k over m. That's all under the radical. And then times t is a variable off to the side is what's happening here. So when I think about relaying Hooke's law, I'm pretty sure it's Hooke's law, to this to one of my previous formulas for cosine, I'm thinking this guy is the same as what the b value is, because it's the coefficient of the variable inside the cosine. So we'll keep that in mind. They go ahead and tell you that the constant of k is 8, and the mass is 2, and that's what gets plugged into the k and the m. So I think they continue and say it was pulled down 5 units. Now, when I read that it was pulled down, what I'm thinking is they're talking about it starting down here. So this function, oh, and I should have done this smaller, but that's kind of the path of the spring. It's going to be pulled down, go back to the original position, spring back up, go down all the way, back to original, yada yada. Oh, I was supposed to graph 2 cycles. I should keep reading. Up, da-da, da-da. I really hope your graphs are better than mine. Alright, anyways, let's write the function first. Y equals, I see now that the a value, it is a 1/2, but because she pulled it down 1/2 of a unit, I'm going to call it negative 0.5 cosine. And then the square root of k over m's square root of that. Let's see, k over m would be 9, square root of 9 is 3. So what I have in my function here is negative 0.5 cosine 3t. Now when they want me to transfer that information to the graph, I think I can handle the upper and lower amplitude lines just fine. If only I could draw. I'm thinking that's a 0.5, and this is a negative 0.5. And of course midline is 0. The important thing for me though is to know the period, which I think they kind of gave us enough information to figure it out. I see now from the formula the b value is 3. So the period, if I use this formula right here, is 2 pi divided by the b value. So he's going to make one complete cycle in 2/3 pi, or 2 pi over 3. Which means this would be 2 of those, so 2 times 2 pi over 3 is 4 pi over 3. And if you had a really mean teacher, which you do, because I'm going to require it, you're going to have to mark off every one of these quarter points. So one cycle all the way through is 2 pi over 3. Half of that would be in the middle. So half of 2 pi over 3 is 2 pi over 6. Cut that, reduce that down would be pi over 3. Half of that would be pi over 6. So I have 1 pi over 6, 2 pi over 6, 3 pi over 6 would be pi over 2. This is 4 pi over 6, which of course is 2 pi over 3. This is 5 pi over 6. This is 6 pi over 6, which is pi. This is 7 pi over 6. And this is 8 pi over 6, which indeed is 8 pi over 3. Ugh, good night. Alright, I think that's your notes. This is tough stuff, so watch it again if you need it. And you will always have these formulas in front of you when you need to calculate the interesting portions of a trigonometric function.